Hi! This instructional video is about measures of central tendency. Measures of central tendency. Basically, it's about mean, median, and mode. Over here it says, find the mean, median, and mode. So, here's a set of numbers, and this actually represents our other side of the neighborhood. Their test scores, their kids, are scoring at 65, 66, 70, 72, and 80, and 82. That's not very good. I mean, it's pretty good. But let's go ahead and find the mean. Mean, as we know, is the average. To find the average, we add up all the numbers together. And so, and that gives me 435 divided by, total of 6 numbers. So 635 divided by 6 numbers. So our average number for these kids is 72.5%. Not too bad. Since we're at it, let's do our side of the neighborhood. In this neighborhood, it seems higher. So let's go ahead and add those up. Does that mean they cheated? I wonder. So that's 540. But divide that also by total of 6 set of numbers. So the average for this side is 90%. Wow. Now it's just to find the median. To find the median is actually the middle of the data. And how do you find that? Well, you simply count towards the middle from one end to the other. From the lowest part to the highest part, you count in. So you go 1, 1, 2, 2. Uh-oh. What's in between 70 and 72? Well, we know it's 71, but to find that, we take the average of those two as well. So we go 72 plus 70 is 142, and divide that by 2, it turns out to be 71. So the median is 71. And the mode? The mode is whatever comes out the most frequent. The most frequent. In this case, there's no number that repeats. They're all different numbers. So there is no mode on this set of data. Now let's go over to this side of the neighborhood. The median for this guy is 78 and 96. 1, 1, 2, 2. Oh, what's in between 89 and 95? Now that's hard to tell, so let's figure that one out. This one is 89 plus 95. Let me use my dummy box to figure that out. So 89 plus 95, that's 184. And then 184 divided by 2 is going to be 92. So the median for this set of data is 92. And what is the mode for this set of data? Well, it seems like 96 and 96 is the most frequent that comes up. So the mode is 96. That's all there is to it. Some kids ask me, what if there's two 96, 96, and let's say there were two 78s? Then we call that bimodal. There are 2 modes. So we would state it as 78 and 96 are the modes for this set of data. There's your mean, median, and mode. Since we're at it, let's go ahead and also demonstrate what is a stem and leaf. Stem and leaf. A stem and leaf is a way of organizing data. It kind of shows you some pattern, but it's a method of organizing set of data. So in this case, let's look at the first neighborhood set of data over here, stem and leaf. Here's how it's done. So we have a vertical line, and on the left side of that vertical line, we draw, in this case, since they're all in tens, we write the tens as, well, I guess we could say 0, 1, 2, 3, 4, 5, 6, 7, 8. I guess I should draw some more here. There we go. 9. Okay? And why not? Put a 10. And so here's how we represent our data using the stem and leaf here. 65, there's 65. 66, there is 66. 70, there is 70. 72, there is 72. 80, there's 80. And 82, there's 82. That's it. This is the stem. And these are the leaves. Is that how you still spell leaves? I hope. Now we can also use a stem and leaf to represent two different datas, so we can compare them. In this case, we could compare the neighborhood A and the neighborhood B test performances. And we would call that back-to-back stem and leaf. So how do we do that? Well, all we need to do is, well, the stem here, we just want to make another line so we could separate them from another set of data that's going to be on the left side. And on the right side, we could call this the A. And on the left side, we could call this the B. And we're going to use the same stem. Except the leaves on this side is going to be a little higher. So the first number is 78. 78. Then we're going to have 86. 86. We're going to have 89. 89. Then we're going to have 95. 95. 96. 96. And one who we think they copied. 96. There it is. And so that gives us a simultaneous representation of the data on the neighborhood A's test performance and neighborhood B's performance. And we could just kind of compare them visually. Another way of organizing data. There you go. Stem and leaf. And stem and leaf back to back.